Right, my solution to Walter Lewin's problem 188, and throughout I consider light as a classical plane wave. So that's the plane, the light is going into the board, the table in this instance, and the orientation of the polarization can be anything like that on the incident light. We will make extensive use of this triangle throughout, and these should be very common values to you. We have cos 30 degrees equals that, hypotenuse, etc. We need to know two things before we proceed. Number one, if this is our incident light, I in, we can break it down into two components. We can have this component along here, which I'll call I out, if that is the plane of the polarizer, and then there is a lost component here. So we have I in, I out when the polarizer is in that direction, and we do need to know that the intensity is proportional to the electric field squared. So let's consider the first polarizer. Light is coming in at all sorts of angles, and the plane of the polarizer for the first one we'll consider as vertical. So I will just very quickly go through what we need to do. If we consider the light coming in, the total intensity is made up of this component and this component, but there are all sorts of different angles, so we need to do a very quick integral. The light coming in, we take the square of these two sides, and we solve this integral. That reduces to 1. We get, for I in, we get is 2 pi I0. For the output, which is going to be this, which is going to be just the cosine term, we need to do this integral, a simple double angle substitution. We get that the I out, intensity coming out, is pi I0, so it's half. So here we go, for the first polarizer, I out is half of I in, but remember we need to work with this, which is the square root of that. So the E field for the first polarizer is a half, 1 over root 2. Okay, for the rest of the situation we've got this. We have our first polarizer, which gave us a value of, for the E, of 1 over root 2 of the incident, and then we move steadily round, and these are all similar triangles: 30 degrees, 30 to 30, 60, 60, 60, and 90, 90, 90. Okay, so for the 4 polarizers. And so you can see straight away that after having lost the E field, the incident intensity is down by a half. That's I naught and this is E naught. Okay, we then subsequently lose the same amount each time, and this value we saw from over here is root 3 over 2, so we simply say root 3 over 2 of that value, getting onto this one, root 3 over 2 of this value, and finally down here this is root 3 over 2 of that. If you put all that together, what you get is here. So first polarizer, half the intensity lost, and we work through this. Down here I've given you the E values, and we find that at the end we get, for the intensity, 27 over 128, or the square root of that, for the E field. 21% roughly of the incident intensity coming in is what we get out, and that actually is about 0.46. You might wonder why we actually work on intensity rather than the E field. If it was radio waves we were dealing with, we'd probably stick with the E field, but we see the intensity of the light essentially, and it's much easier to think about intensity. So that's that. If we come over to part B of the problem, we can see that we're going to lose one of these two polarizers, and that's fairly easy to see. Let's say we take out this polarizer here. What we're going to get is now a 60-degree angle, so the light will come down to about there, and I'll draw it in with a different colour. That colour doesn't matter. So we come down and the light does that. So sorry, the cosine of 60 is this. So what we've got now is that's what we're keeping. We've got that coming in. On the next polarizer we keep that, and so we would then come down. It's easier to do it freehand. We'd come down here, and what we get out is this. And it turns out that if we do the calculations, this is actually 2/3 of the first result. Equally, if we put that one back in and took this one out, what we'd find is that we were doing, I'll do this in a different colour, we would find that we took this cosine along here, this will be that to that, and then we'd jump down the 60 degrees, and again we'd find, actually, no surprises, we end up at the same spot down here. Okay, if you take out both of them, it should be fairly straightforward that the triangle that you're making, the two components, you end up with just nothing going through. So for part 3, you get nothing at all